We'll now look at another example of using control charts, and this is in the area of syndromic surveillance. In the aftermath of the terrorist attacks on September 11, 2001, people were worried about other kind of terrorist attacks that might be bioterrorist agents, such that they would manifest themselves in flu-like symptoms in the initial stages. So really we wanted to see whether you could detect an increase in flu-like symptoms by monitoring the number of emergency visits with such symptoms. The idea, of course, being early detection would lead to mitigation. At that time, we had no idea that of any impending pandemics, and so this, if it had been in place, might have been useful at the initial stages to detect flu outbreaks in Wuhan. Might have been. So the question were, can we detect a flu-like outbreak, and if so, how fast? And then secondarily, can more sophisticated statistical methods do better than simple methods, where the simple methods is the Shewhart method, one observation or one subgroup, and the more sophisticated are the EWMA CUSUMs, adjusted CUSUM. We had data from the George Washington University Hospital Emergency Department between 1998 and 2001. You see them here, their daily data. And these are the number of patients that were in the emergency department with flu-like symptoms, or, and there's a second medical category, viral, not otherwise specified, but basically flu-like symptoms. And so here you see the number, and well, it goes from 0 to 10, and then during the flu season, it goes higher sometimes, up to about 20 person in just this one hospital, right? And so we are only interested in increased counts of flu-like symptoms, so we don't need to worry about a decrease, because terrorist attacks wouldn't manifest themselves in the disappearance of the flu. Okay, so what we did is we simulated outbreaks. So we assumed that there was no outbreak going on between 1998 and 2001, other than the regular flu season. And then we simulated them. And we had two kinds of outbreaks in mind: a fast outbreak, where we added 3 flu counts here, and then 6 on the second day, and 9 on the third day. All right. Well, that's as straight as it's gonna get. And then we had a slow outbreak simulated, where we add 1 observation for 3 days in a row, and then 2 observations for another 3 days in a row, and then 3 observations for another 3 days in a row. So that's a slow outbreak. Now, this is just an example here, right? So we had the data, and then we simulated and again fast and slow outbreaks, starting at random times, just by adding these things, right? And so we did that separately for slows and fast outbreaks. We didn't do it all on the same plot. Okay. Now for the one-sided mean-adjusted CUSUM, we used the same formula that we have introduced in this course. Well, it's an equivalent formula. There's a slight different parameterization of the K sigma in the paper, but it's the equivalent formula. The control limits are set empirically, so such that the parameter values for alpha in EWMA and the K times sigma in CUSUM are chosen such that we wouldn't get more than 1% false alarms. Now, usually we don't have a control limit for the CUSUM, only for the mean adjusted CUSUM, but we set them empirically here because of that, that was feasible. So the experiment that we ran was split by whether or not we were in a flu season or not. The flu season was from December 1st to April 30th, and the off-season was the rest of the year. We conducted the experiment separate by whether or not we were in the flu season or in the off-season. And we seeded the data, as I mentioned, with fast and slow outbreaks, and then assessed the sensitivity. All right, now, here we have in the off-season the probability to detect the attack on the fast attack on day 1, day 2, and day 3. And so what you see is on day 3, we detect it always, regardless of method. Day 2, we have more or less a 50% chance, regardless of method. Day 1, no chance, more or less. Okay, the slow attack, also in the off-season, can be detected with increasing probability, and in day 9 we finally have 50% probability. So a bit oversimplifying that, we really need 9 days to have a decent chance at detecting it, where decent is here 50%, and before we have just a very small chance. All right. The graphs for the flu seasons are not shown, but basically we have no chance at detecting it during the flu season. So it really only works during the off seasons. That reminds me, the coronavirus in Wuhan started during flu season, so this might not have worked. So the previous slides showed that the Schuhart charts don't detect slow attacks well. And there's really no difference between CUSUM and mean adjusted CUSUM, but really we weren't expecting any. Timely detection is difficult, not at all in the flu season, and in the off season, we have a 50% chance on the last day of the slow attack, well, day 9 of the slow attack, and on 2 days of the fast attack. Yeah, and the methods that use the history, meaning CUSUM and adjusted CUSUM and EWMA, are preferred over the Schuhart method. That ends this segment, and it ends the course. I hope you enjoyed it. If you're in my class, I'll see you during office hour.